Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Math 113, Term 232, Major 1. Let us have a look to the exam and solve it together. Use the definite integral, the definition of the definite integral, the limit of Riemann sums to evaluate this integral. Well, we know that the definition says the integral from a to b for a function f of x dx is equal to limit when n goes to infinity of summation I from 1 to n f of xi delta x. This is the definition of the definite integral, and this is limit of Riemann sum. What is delta x? It is b minus a over n. So this is b and this is a. We divide by n. And what is xi? The definition of xi, it is a plus I times delta x. So here, what is a in this question? A is 0, b is 4. So what would be delta x? It would be b minus a, so 4 minus 0, which is 4 over n. Notice that to evaluate the integral, I'm going to use this definition. So first I find delta x, then I find f of xi. What is f of x here? In this question, what is f of x? F of x is this one, inside the integral. So f of x is 3x squared plus 4. That's f of x in this question. Okay, so let us find xi. What is xi? It is a. What is a? 0. So 0 plus I delta x. Delta x is 4 over n multiplied by I. So 4I over n plus 0. So this is xi. Okay, so I have delta x, xi. I need f of xi. So what would be f of xi? I replace x by xi. So it would be 3xi squared plus 4. But what is xi? Xi is 4i over n. So 4i over n squared plus 4. This is f of xi. Let us simplify it. So this would be 3 times 4 squared, which is 16i squared over n squared plus 4. 3 times 16, I can write it 48 I squared over n squared plus 4. This is f of xi. Well, I have f of xi, I have delta x. So let me find the sum, the Riemann sum. Summation I from 1 to n. F of xi delta x would be equal to summation I from 1 to n. F of xi is what? Is 48 I squared over n squared plus 4. I need parentheses because there is a sum here, addition of two terms, times delta x. What is delta x? 4 over n. Well, 4 over n, there is no I in 4 over n, so it's a constant. So you can take it if you like outside the summation. And then I'll have summation 48 I squared over n squared plus I can write summation 4. So I can distribute the summation among these two terms. So for summation 4, 4 is a constant, C. So there is a formula that says summation C I from 1 to n is equal to Cn. And also there is a formula for summation I square. All of these formulas are on the course, and you can check them if you like in the videos. So the formula says n times 2. Let me write n plus 1 first. N times n plus 1 times 2n plus 1 over 6. This is summation I squared. So I have 4 over n times the first summation. Well, the first summation, I have 48 over n squared. This is just a constant. Okay, so let me multiply 4 over n times 48 over n squared. 4 times 48 is 192. And n squared times n in the denominator will be n cube. Okay, and I will have summation I squared plus 4 over n times this summation. What is summation 4? According to this formula, it is 4n. So this would be equal to 192 over n cubed. What is summation I squared? n plus 1, 2n plus 1 over 6. And here n cancels with n, and 4 times 4 is 16. Now 192 over 6 is 32. And n cancels with 1 of n cubes. So I'll have n plus 1 times 2n plus 1 over n square, because 1 of the n cubes I cancelled with n, plus 16. So this is the Riemann sum in simplest form. And I need to find now, according to the definition, I need to find the limit when n goes to infinity. So let me take the limit when n goes to infinity to this. Well, I have 32. Let me write it again. N plus 1 times 2n plus 1 over n square plus limit 16 when n goes to infinity. Well, when we take n goes to infinity, we take the highest power from the numerator. So the term with the highest power, we will have 2n squared. If you multiply these two, if you expand these two brackets, I'll have n times 2n squared. That's the highest power. So I'll have limit n goes to infinity of 32 times 2n squared, because that's the highest power, over n squared below. And the limit of 16 is 16. There is no n there. And now I can cancel n squared with n squared. So this number would be 64. The limit of 64 is 64 plus 16. So the answer is 80. And you can check that your answer is correct by asking the calculator to evaluate this integral. Calculators can evaluate definite integrals. The graph of f of x is shown. Evaluate the integral from -3 to 3. So this is -3. I draw this line. To 3, I draw this line. And I need to find the area below the definite integral is an area. So in this region from -3 to 3, I have this rectangle and another rectangle, this rectangle. So if I find the area of this rectangle plus the area of this rectangle, I'll get the definite integral. Interpreting in terms of areas, you have to use the areas. Okay, so area of rectangle. What is the area of a rectangle? Now what is this? This area of a rectangle is half base times height. So this is the base, the length is 2, the height is -2 here. You know this rectangle is below the x-axis. The height is negative. So integral from -3 to 3 f of x d of x would be equal to, let us find the area of the small rectangle. 1 over 2, the base is 2, the height is -2. And the other rectangle, the base is, this is 3, this is 1, the base is 4, the height is 4. So plus half times 4, the base times the height is 4. So here I'll get -2, and here I have 2 times 4, that's 8, and the answer is 6. If you want to check your answer here, you can find the equation of this line. This is something beyond the answering the question. This is just for you if you want to find whether your answer is correct or not. So you can find the equation of this line, and this line passes by points -1, 0, this point, and the point 0, 1. So the slope would be 1 minus 0 over 0 minus minus 1. So the slope, in fact, is 1. And the equation of the line y minus y0, I'll use this point. Y minus 0 equals m, which is 1, times x minus x0, which is minus 1. So it would be plus 1. So actually, the equation of this line is x plus 1. So this function is actually x plus 1. So you can use the calculator to find the integral of x plus 1 from -3 to 3. And you will find that the answer is 6. All right. So this is just, please, this is just for checking, okay? This is just checking. It's not answering the question. So you don't have to write it in the exam. Okay. Find the derivative of this function. Well, we have fundamental theorem of calculus. It says that the derivative of the integral, okay? Let me write the formula for you if you want to remember it. D by dx of the integral from a to x, where a is a number and x, f of t dt, you have to memorize this formula is equal to f of x. So this is the fundamental theorem of calculus, part 1. But here I don't have a number, I have ln x and I have x cubed, I have two functions. So we can generalize this formula and make a general formula when we don't have a number here, when we have a function, for example, g of x, and we have a function here, up, not x, so h of x, like x squared, x cubed, ex, whatever, times f of t dt. So this is exactly this form, because g of x here is ln x, h of x is x cubed, and f of t is square root of t squared plus 3. So the answer would be, instead of f of x, I'll have f of, remember, I replaced t by x. So I have here h of x. So I remember, sorry, I will replace t by h of x. So f of h of x. But this is a function, so I need to multiply by its derivative minus, and now I do the same for g of x, f of g of x times g prime of x. So you can use this formula when you have a function below and up. So to answer the question, f prime would be d by dx of this, which is replace, go to the square root. I have square root of t squared plus t. This is f of t. Replace t by the function up, which is x cubed. So I have x cubed squared. So I replace t by x cubed plus 3. This is the first part. This is f of h of x times the derivative of x cubed, which is 3x squared, minus Now I do the same. I write the square root. But this time I replace t by the function below, which is ln x. So ln x squared plus 3. And I multiply by the derivative of ln x, derivative of g, which is 1 over x. That's the answer. If you want to write it in another way, you can write 3x squared first, and x cubed squared is x to the power 6. And here you can write it ln x all square plus 3 over x if you like. If you stop here, it would be fine and you will get the mark. Okay, evaluate the following integrals. Well, here I can use the formula. There is a very important formula, which is a plus b over c. You can write it a over c plus b over c. Whenever you see something like a plus b over c, you can write it like this. So I'll immediately use it and write here square root of x over x minus 2x over x. But you know that square root of x is x to the power half. And you have x to the power half up and x to the power 1. What should you do? You subtract the powers when there is a division. So I'll have x to the power half minus 1. That's negative half minus. Here x cancels with x and you have 2. So that's it. Now I can find the integral. What is the integral of x to the power negative half? It is x to the power negative half plus 1. You add 1, which is half over half minus 2x. The integral of 2 is 2x from 1 to 4. Well, over half means 2. So I'll take 2 minus 2. I'll take 2 as a common factor outside. And I'll have square root of x minus x inside from 1 to 4. You can replace x by 4 minus replacing x by 1 without taking 2 outside. It's not a big issue. So now replace x by 4. Square root of 4 is 2 minus 4 minus replace whatever here, x by 1. Square root of 1 is 1 minus x, which is 1. 1 minus 1 is 0, so I'll have 2 minus 4, that's negative 2. Negative 2 times 2 is negative 4, and that's the answer. And again, you can check your answer because the calculator evaluates definite integrals. I have x cubed outside, x to the power 4 plus 2. I notice that the derivative of x to the power 4 is 4x cubed. I have x cubed outside, so I'll use integral by substitution. So I take u equals x to the power 4 plus 2, what is inside the radical. And I find du. Well, du is derivative of x to the power 4 is 4x cubed, and derivative of 2 is 0 times dx. So this is du. Now I need to change this integral from x to u. Well, I have x cubed dx. X cubed dx, I need 4. So let me write 4 here. So now I have 4x cubed dx, it would be du. But I cannot just write 4 here. If you write 4 here, write 1 over 4 outside. So now you cancel 4 with 4 and you go back to the question. So the integral would be 1 over 4 integral. Now 4x cubed dx, that's just du. I have the square root of x squared, x to the power 4 plus 2. X to the power 4 plus 2 is u. So I'll have square root of u. So I can change this integral from x to u like this. And this is an easy integral because square root of u is u to the power half. And u to the power half, what is the integral of u to the power half? You add 1 to half, so it would be 3 over 2. You divide by 3 over 2. But dividing by 3 over 2 is multiplying by 2 over 3, the reciprocal, plus c. So the answer would be 2 cancels with 4. I have 1 over 6. Now go back to x. What is u? X to the power 4 plus 2. So write x plus to the power 4 plus 2. And instead of u, don't forget the power 3 over 2 plus c. That's the answer. Well, I have cosine x over 1 plus sine square x. if you look carefully, you find that derivative of sine x is cosine x. So if I let u equals sine x, then du would be cosine x dx. And let me change this integral to u. So I have here up cosine x dx, and that's just du. And down in the denominator, I have 1 plus sine squared. But sine is u, so sine squared would be u squared. So I changed this integral from x to u, and now I have this integral. What is the integral of 1 over 1 plus u squared du? Well, if you know the formulas, then you know that the integral is tan inverse u plus c. And u, you have to go back to x. U is sine x. So that's the answer. If you know the derivative of tan inverse, you can check your answer here by finding the derivative of this. And you will find that the derivative is equal to this. What is the derivative of tan inverse? X, tan inverse u here we have. It would be 1 over 1 plus u squared times the derivative of u. So it would be 1 over 1 plus sine square x times the derivative of sine, which is cosine, and derivative of c is 0. So you will get really this function, so our answer is correct. Also here, if you find the derivative of this function, 3 over 2 times 1 over 6 times this parenthesis to the power 3 over 2 minus 1, which is half, times the derivative of x to the power 4 plus 2, which is 4x cubed. If you simplify, you will find exactly this function. So this makes you feel comfortable that your answer is correct. Find the area of the shaded region enclosed by the given curves. Y equals to x. This is the line. And this is the cubic function y equals x cubed minus 3x. Well, what is the formula for the area? Well, the area is equal to, the formula of the area is integral. There is an area when you have dx, and there is a formula also when you have dy. So which one I'm going to use here? Well, I'll use this rectangle because I have this function, which is x cubed minus 3x, always above the line. So I'll use a vertical rectangle. When I use a vertical rectangle, the width of the vertical rectangle is dx. So I need the formula for dx. So integral of AB, the height is f of x minus g of x times the width, which is dx. So it's a rectangle, and that's the height, and that's the width. So, but I have two regions here because in the region to the left, the curve is above the line, but the region to the right, the line is above the curve. Well, if you look carefully to the graph, you notice that they have the same area. This region has the same area like this. So they have the same area. So if you want to use one of them and multiply by 2, that's okay. So you can say, I'll not do that. I'll just find the area, two integrals from x runs from where? dx. So x runs from where to where? Well, x here from negative 2, 2, so x is negative 2. So x for the region to the left is from negative 2 to 0. And the function above it is x cubed minus 3x minus the function below, which is x. So this integral will give you the area of the shaded region to the left. The shaded region to the right from 0 to 2, x is from 0 to 2 because you have dx. And above I have the line x minus the curve. And pay attention, minus before the curve. So this minus will change the sign of x cubed and the sign of 3x. So I'll have integral from negative 2 to 0 x squared x cubed minus 3x minus x is minus 4x. And here from 0 to 2, x plus 3x is 4x minus x cubed. You can see here that if you change I'll do it here. If you change the limits of the integral. Instead of -2 to 0, if I write it 0 to 2, then you have to put a minus sign. So if you change this from 0 to 2, you will have a minus sign here, so you will have this one. So in fact, I can write, and this is equal to 2 times integral from 0 to 2, 4x minus x cubed dx. Or if you like, 2 times the first one, times integral from -2 to 0. So I'll do it like this. 2. Now the integral of 4x is 4x squared over 2. That's the integral of x squared over 2. And x cubed, the integral is x to the power 4 over 4, and from 0 to 2. So I have 2. Now replace x by 2. Notice that 4 over 2 is 2. So I have 4 times 2, that's 8. And here, 2 to the power 4 is 16 over 4, that's 4. So this is when I replaced x by 2. Now replace x by 0, I'll have 0 minus 0. So that's it. So 4 times 2 is 8. So in fact, the area is 8. Sketch the region enclosed by bounded and bounded by the curves y equals x, y equals 0, x equals, okay. What is the graph of y equals ex? Well, we know that this is the graph of y equals ex, the exponential function. Y equals to 0, it is this line, y equals to 0. X equals to 0, it is this line, the y-axis. And x equals to 1 is this line, x equals to 1. So where is the region? This is the line ex. This is y equals 0. This is x equals 0. This is x equals 1. So it is this region. About the x-axis, we need the volume when we rotate about the x-axis. So when you rotate about the x-axis, what would you like to choose here? What would be the rectangle you choose? Vertical rectangle or horizontal rectangle? If you choose a horizontal rectangle, then you have to divide the area into two areas, because from here to here, this line is to the right, but up this line is to the right of a curve. So the best choice here is to choose a vertical rectangle. When you choose a vertical rectangle, this means the width is dx. And when you rotate this rectangle about the x-axis, what would you get? If you rotate the rectangle about the x-axis, you will get a disk. And you know if the rectangle is perpendicular to the axis of rotation, it's also, you have a disk or washer. But here we will have a disk because there is no space between the rectangle and the axis of rotation. So what would be the formula? The volume would be integral from A to B pi radius square dx, because the width of the rectangle is dx here. All right. So x runs from where to where? From A to B, here from 0 to 1. What is the radius of the disk? Well, the radius is the distance from the axis of rotation to the curve. So this distance, this is really, when you rotate, this is the radius. So what is the radius? What is this distance? This vertical, the blue one, it is from 0 to ex. So this point represents f of x or ex. So this is ex. So the height or the radius is ex squared dx. That's it. What is ex to the power 2? There is a formula, you can multiply the powers. So it's in fact, you can take pi outside. It is in fact e to the power 2x. What is the integral of e to the power 2x? E to the power 2x over 2. Okay, over 2. That's the integral of e to the power 2x. You divide by the derivative of 2x from 0 to 1. If you replace x, so I have pi over 2. If you replace x by 1, I'll have e squared minus, if you replace x by 0, I'll have e to the power 0, which is 1. And that's the final answer. That's the exact answer. You don't have to, approximate that answer. Sketch the region enclosed by these curves, ln x, ex, x1, x2. Well, this is the graph again of ex. This is the graph of ln x. This is the number 1. This is x equals 1. This is ln x. This is ex. And the line x equals to 2. So if this is 2, then this is the line x equals to 2. So where is the region? It is this region. And we need to rotate this region about the y-axis. So what kind of rectangle are you going to use? If you use a horizontal rectangle, you have to divide this region into 3 regions because there is no curve always to the right of another curve. In the first region, this curve is to the right of the line. Here, the line is to the right of the line, and then the line is to the right of the curve. So horizontal rectangle is not good here at all. But vertical rectangle would be excellent. The width would be dx, and we will always have this curve, which is ex, above the curve ln x in all of the region. But the axis of rotation is the y-axis. So the rectangle in this case would be parallel to the axis of rotation. So when you rotate this rectangle about the y-axis, you will not get a disk. You will get a cylinder. So you have to use the formula of cylindrical shells. So the volume would be AB, and again I'm going to use dx because the width is dx, so I'll have 2 pi x, that's the formula, times f of x dx. So he just needs the formula without evaluating. A is 1, B is 2, dx runs from 1 to 2, 2 pi. Now what is x? X is the radius of the cylinder. So when you rotate a cylinder, this is the radius, the distance from here to here. And the distance from here to here is x. So x. So I just write the x, which is the radius. And f of x is the height of the rectangle. And to find the height of the rectangle, it is the above curve minus the lower curve. So ex minus ln x. And that's it. This will give you the volume of this region when you rotate about the y-axis. This was the last question. I hope you will benefit from looking to the solutions of this exam.